Hello, my name is Pedro Morales. I'm a teaching professor at the Math Department at the University of California, Santa Cruz, and this is Math Talk. Let me share some of the ideas that we talked about in our classes of linear algebra and precalculus. But before of that, let me just start by sharing some thoughts of studying. I think that the way we study is very important in our success in classes. It is not only a matter of being able of doing the exercises, but also to remember what we have done in class. So studying becomes essential. By studying, what I mean is reading notes, checking your own class notes, to create concept maps, to create flashcards, and to review after every class. This becomes very important, not only for being able to work out the examples, but also to remember all the important concepts in class. A general rule is not only to use your entire time in practicing problems, but also studying as well. Even more in mathematics, this is very important because often people forget about this and they just work out problems. So studying becomes very essential. In some sense, you want to divide your time not only for working out problems, but also for studying. And the specific time that you allocate for each of them depends on your learning style, but it is important to remember this all the time. Now let me start talking about what we did this week in our class of linear algebra. We talked about determinants and how these are very important for describing solutions of systems of equations. Even more, it becomes important in order to classify matrices as having inverses or not. This is equivalent of saying that a specific sequence of vectors is linearly depending or not. This becomes very central then whenever we start describing properties of vector spaces. We talked about different components that will help us to compute determinants in general, which could be a recursive process. So in this case, we usually have our determinant expansion with respect to a single row. Depending on which row we check, we have different types of expansions. So usually a practical rule is to check the row with the most zeros because that will make it easier. In order to do this, we resort to the idea of minors and cofactors. This will give us a very nice expression for a generic formula involving determinants. We also talked about abstract vector spaces, which in some sense, it's a little summary of what we already did with Euclidean vector spaces. The idea is that now we can talk about polynomials, matrices, or other kind of sets that actually behave like vector spaces. The nice thing about this is that whenever we have a finite dimensional vector space, even if it's an abstract vector space, we have that the coordinate vectors actually resemble the ones with Rn. So we can really think about them as elements in Rn. And finally, we talked about the span of abstract vector spaces and the idea of linear dependence, which is basically the same thing as before. We would have a dependence relation and we need to check how many non-trivial solutions we have for that system. On precalculus, on the other hand, we talked about one-to-one functions, which became a very important concept in order to describe inverse functions. We wanted to describe inverse functions because so far we've been collecting these different types of models that we use in order to describe reality. We talked about linear, quadratic, polynomial, and rational functions, but now we actually start talking about something a little bit more complex involving exponential and logarithmic functions. The important relation between exponential and logarithmic functions is that they are inverses of each other. So the idea of one-to-one functions becomes really important. In other words, the idea of having just a single y value for every single x value and vice versa becomes very relevant in here because that way we can define an inverse function. In other words, an inverse function allows us to solve equations. That's the main point. We can solve an equation whenever we have a one-to-one function. So when talking about exponential functions, we discovered that they are one-to-one, which means that we can solve exponential equations. Whenever we do this, the solution of that equation we call the logarithm. So we compared the exponential properties with the logarithmic properties, and they actually go hand in hand. So it is very important to remember this, because if you remember the properties of exponential functions, it's really just the same thing as the properties of logarithmic functions. Now we are going to put this together to create more robust models for real life situations. And we are going to use the idea of composition of functions, as we already talked before. So basically, those are the main ideas that we covered in our classes this week. I hope this makes a little bit more sense, and stay tuned for another episode of Math Talk.